All right, hold on tight. Okay, this is that bike that we were talking about before. It's got the color-coded stuff, okay? Now, it's too complicated to talk about a whole bike right now, so we're just gonna work on the front end, okay? Now, this is a bike. These center of mass numbers are for the bike in its saddle down position, changes the center of mass slightly. I'm effectively standing on the pedals, and I'm over here, and we're gonna look at front end values. That's the bike as it stands. And my example intention was, okay, but you're PVD, you run these wacky ass handlebars. I'm not some goon, I'm a cool guy on pink bike. I can't run that kind of stuff, you know? What I think someone said, set it on fire was a comment, you know? Okay, so let's just say you can't bring yourself to do it because you're too damn cool. I get it, you know? Peer pressure is a thing. So, from here to here, I actually just to make it easier, I took out that spacer that I had added on the lower headset stack, and I normalized it. So this is, we're starting again. I've changed a couple numbers just to kind of normalize it. You say, corrected lower headset to 1 millimeter for consistency. This is going to be our starting point. Now we're going to go to another bike. Okay, you dropped in a 35 millimeter stem and some 28 millimeter rise bars. What's that, 1 1/4 or something like that? Traditional bars and stem. We have, notice, throughout all of this, we're going to keep our hand grip position consistent because we know where we want our hands, right? That's something that's part of our fit. We want our hands where we want them, so we can fix that point. But to do that, to put these on here, we had to slack the head tube angle to 59.3 degrees. Even in today's market, that would be considered extremely slack. Now, I said earlier that head tube angle was trivial, and I believe it. But the thing is, we're not working with a full rigid bike here. We're talking about a suspension fork. It's like a 160 fork, right? Any folks know what stanchion bind is? Stanchion bind is a real thing. The more you slack your head tube angle, and if the force vectors are going normal to earth, you're trying to fold your fork right where the bearings are. And that stops it from moving. So when you end up with seriously, that's why I've got steep head tube angles. I'm trying to get my fork to work better, not worse. Remember we talked about design for 99% of your ride? In what percent of most people's ride on trail do you think that head tube angle is going to align with the forces going through the fork? An extremely small percentage of the ride. Now, for the other 99% of the ride, is it going to effectively start locking out that fork? Yeah, stanchion bind is going to be wicked on this thing. The more weight you put on the front end, the less that fork is even going to want to move. So that's kind of bad. Also, we started with 101 millimeters of trail and 39 millimeters of flop. Now we're up to 147 millimeters of trail and 75 millimeters of flop. You want to talk about wacky. That thing's going to feel like a clown bike. And it's not going to feel light at all. It's going to feel like a ton of bricks because we've just effectively multiplied by 1.5 on our mechanical trail, right? Okay, so we go, I'm cool, but I'm not that dumb, right? We're going to change our setup, and we're going to use an imaginary fork. This fork has 90 millimeters of offset. Before, we were on a fork that was otherwise available. Handlebar, everything's available here. Now we're in a land of imagination where, and this is why I said earlier, prototyping with full rigid bikes gives you the advantage of changing all these stuff, and you could do this. Well, you could do that with suspension forks if you're building suspension forks, but not too many people are. Anyway, so to keep our hand grips in exactly the same place, and we're correcting, we're going to increase the fork offset. So we got our front wheel trail down, but we still got a fairly high flop right here at 52 instead of 39. And to keep our hands in that same position, we had to run an 81 millimeter stem, you know? So we kind of made it better, but we're using an imaginary fork. It's not great at this point. We've still got insane stanchion bind, but maybe it's not steering as horrifically heavy as it did before. Okay, so we say, well, we're going to fix that. Oh, we're smart. We're going to increase the head angle. We're going to fix the stem length, and we're going to reduce the offset, still with an unavailable offset of 75 millimeters. But we've kept, again, our grips are in exactly the same, pretty much exactly the same location. I think there might have been a deviation there. But if you notice, now we're at a 62-degree head angle. That's still too slack, I think, from a stanchion bind situation. I think anytime you get below 65 and you're not downhill racing or really enduro racing, you're really doing yourself a disservice, because it's really causing more problems than it's helping you out at all. So we're using an imaginary fork, and we were able to get our trail is all right, but we're still high on our flop. It's still feeling pretty goofy. Okay. Now we get wise, and we reverse our stem. We turn our stem backwards, because does the stem care which way it's pointed? It doesn't, does it? It's a pretty meaningless functional strut. It doesn't matter. In fact, I'd argue it's stronger when used reversed mechanically from a structure point of view. So we reverse the stem. Look at this. We got 40, our flop is a little off still, but we've brought our head tube angle to 67.3 degrees. And look, we're using a conventional fork. Our hand grips are in the same position. I'm sorry, I didn't mention, in every one of these examples, notice our front center is staying 850 the whole time. Our front wheel and our grips are in the same location in every example, because those are things we really care about. We're trying to fine-tune steering and handling details of the front end, okay? And then we reverse the stem, so 67 millimeter stem reversed. Well, what's the difference between this and the first example? Now, because we go, bro, I'm no kook. I'm not running my stem backwards like a noob. Like, this bike was put together at like the Canadian Tire or something, you know? So, okay, we're going to use a traditional stem. We're going to use traditional bars, except these are those big 16-degree SQ Lab bars. My head tube angle is 67.3, all this stuff, but I've reduced my front center 55 millimeters so that I can use these traditional components with a fairly steep head tube angle, and I've had to reduce my front center. Well, that's shorter than my wife's new bike. But this is supposed to be for me. I ride an 850. I don't run a sub 800. That's a road bike. So we bring it out, because we say, okay, we're not going to run as steep a head tube angle. We're going to bring it down to 65. It's fairly, you can get away with 65. A lot of people are doing 65. Got our hand grips in the right place. We're using a conventional 40 millimeter stem. We're using those nice 16 degree back sweeps, and we've brought our front center out to 825. And you'll notice that you're starting to see a lot of bikes with the 820s in this size range. That's why. Because that's the most you can get away with for most people to fit on an aggressive real-world mountain bike setup. But you're not going to get the 850, which is an inch longer than this that I tend to run, until you start doing some goofy stuff with your handlebars. Okay? I wanted to take you on that journey to a world of imagination. But this is what you can do when you're drawing your bike. This is what you can do when we have our geometry written down and we play with imaginary scenarios and play what if. But then we get this. And this is a bike you can build with conventional parts. Compared to most bike for sale, it's probably going to be a pretty nice bike. You know, there might even be a bike that's close to that. That's starting to happen. Specialized was one of the first with that one, where they really got to the limits of what can be done. But remember, it's the stem and handlebars that's limiting the system. So when you look at PVD's wacky setup, it's because I needed to decouple from this so that I could do anything I wanted with my front wheel and still have my hand grips where I wanted. And you know, when I change this, now we go back to our, I'm going back a slide. This is our COM angle, and we go from 63.8 to 52.8. Just by bringing it out that last little inch from the easy ass stuff before, I've given myself an extra angle on my COM to front contact patch angle, which is far more stable when I'm going into the rough rock garden and things like that. I'm not going to go over the handlebars as easy. And that's how we're looking at it with this.